So I had to trim my last video because I had a distraction going on in the background, but I'm going to pick up from here relatively quick because I want to close this out. So we're going to end using identities to rewrite any of the 6 trig functions and any of the other terms. There are a couple examples of these done out in your book, so I refer you to that for more examples. But with no further ado, write cosine in terms of tangent. So these are kind of challenging because you got to have be well versed. But I just want to keep in mind that you probably want to look at your Pythagorean identities because they're typically the most helpful, or your quotient ones. Okay, but I'm gonna recall that tangent squared plus 1 is equal to secant squared x. All right, and so now, why I'm starting there is because it says we want to have something, we want cosine in terms of tangent. So here's something that at least gets me tangent, but what I don't have is cosine yet. All right. However, the secant is 1 over the cosine, and so the secant squared is 1 over the cosine squared. So this is nice. This is nice. So using a reciprocal identity, I'm able to convert secant squared into 1 over cosine squared. And now if I kind of invert both sides here, or reciprocate each side, I get 1 over tangent squared x plus 1 equals the cosine squared of x. And then clearly I can take a square root of both sides. 1 over tangent squared x plus 1 equals, oh, and I should put a plus and minus sign here, the cosine of x, right? And so there's our final answer. Of how to do that. So again, I refer you back to the book for more examples. Lastly, so I stated that because all the trig functions are related by identities, we can find the values of an angle given one trig function and the quadrant that it's in. So again, there are other examples of this, at least one example done out in the book. I'm going to do one here. So suppose we're told that the cosecant is the square root of 3 and that the angle of rotation is greater than 0 but less than pi over 2. So you should immediately notice that this is a quadrant 1 angle. And in quadrant 1, all of the trig functions are positive. All trig functions positive. All right, but in other quadrants, that's not necessarily true, so keep that in mind. Well, we can proceed as follows. Given that we have cosecant, we can refer back to identities that cosecant, I'm sorry. Cotangent squared plus 1 is equal to the cosecant squared. And since we know that the cosecant of x or of alpha is square root of 3, we can substitute this in. Which means our cotangent is equal to 3. If we subtract 1 on both sides, we get the cotangent squared is equal to 2. Taking a square root, and I'm going to choose the positive because quadrant 1. And there we go. There's one of the other 5. We know the cotangent is the square root of 2. If we know that the cotangent is the square root of 2, we can find the remaining trig functions. How? How can we do that? So